All right, so everything is good, ready for whenever you want to start. Okay. All right. So, hello, everybody who is here, who is yet to join. My name is Rochelle Robinson, and today we're going to be doing some CSEC mathematics topics. We're just going to do some past paper questions. I'm going to walk you through some questions. So we're doing geometry and trigonometry, as well as functions, graphs, and relations. All right, so getting into it now. Just a welcome screen. All right, so let's attend some questions, starting with geometry and trigonometry. And if time allows, we're going to cover a lot today. All right, so the first question is a paper 2 style question. And basically, it is showing us here, right angle triangle. We have our sides labeled A, B, C, and an angle labeled theta. So it's saying using the diagram, part 1, using the diagram, express C in terms of A and B. So side C in terms of A and B. So basically, the first thing that you want to think about is what knowledge this is asking for you to put into practice. This is a right angle triangle. So things that are true about right angle triangles are Pythagoras Theorem, and your Trig Ratios as well. So this here is relating to Pythagoras Theorem. Where the hypotenuse, so I'm going to literally write hypotenuse squared. So the dimension of the length of the hypotenuse squared is equal to the length of your two sides, whatever the name of the sides are. Here I'm just going to name them A and B. So A squared, side A squared plus side B squared. So the length of the hypotenuse squared is equal to the length of your side A squared plus your side B squared. All right, so relating this information to Pythagoras theorem, because that is what this is this is asking us to call to knowledge. Side C would be our hypotenuse, so it's going to be C squared, and I can just bring back A squared plus B squared. And the Pythagoras theorem is written many different ways. This is just one of those ways. This is another way too that you can write Pythagoras theorem. All right, so we know that C squared is equal to A squared plus B squared. Now we want to know what is C. So we know C squared, but we want to know just C in terms of A and B, which means that we need to get rid of the square, the square sign here, and bring it to the next side, for lack of better words. So to transpose that square, we're going to find the square root of everything here. So the square root of C squared and the square root of A squared plus B squared. That's going to look a little bit like this. Square root of C squared equal to the square root of A squared plus B squared. Because what you do on one side, you do on the next side. So square root sign cancels out the square. So it's going to be that. What you're just going to have left is C equals to root A squared plus B squared. We can't simplify here because we're adding, of course, and so it's just going to be that all the way at the end. Okay, so if everyone is clear on the first part, let's move on to the second. 1 second. Right. For part B, using the diagram again, write in terms of A, B, and C an expression for sine theta plus cos theta. So like the last time, you're going to think about what the shape is, what we know about the shape, and what ideas that you would want to bring to knowledge while working on a particular part of the question. So last time we did Pythagoras Theorem. Now this is referring to our trig ratios, sine theta and cos theta. Now we know that sine theta is equal to opposite over hypotenuse, and cos theta is equal to adjacent over hypotenuse. So with that said, and we know that theta is this angle right here, we can then just write the corresponding names of the sides where opposite and hypotenuse fall. So sine theta, using this theta here, our opposite line, our opposite side, sorry, is going to be A right here. And our hypotenuse, as mentioned before, is C. So sine theta is going to be A. So just using these lines to label A, and their hypotenuse is C. So sine theta is A over C. Now cos theta, once again, our theta being our angle right here, cos theta is adjacent over hypotenuse. Our adjacent side is the side that is directly touching the angle. So our adjacent side is going to be side B, and our hypotenuse is the same, side C. So cos theta is equal to B over C. So now that we know sine theta and cos theta, we can write sine theta plus cos theta, which is just going to be A over C plus sine theta plus cos theta equal A over C plus B over C. All right, and we can further simplify this because C is, it has a common denominator. C is a common denominator here. We can just simplify and say A plus B all over C. All right, so that is the second part of that question. Moving right along. So using the results from part A and part B, show that sine theta squared plus cos theta squared equal 1. So this is a little bit similar to proofs and trigonometric identities, where you would, if you do add maths, you would be familiar with that. So here we're just trying to prove that sine theta squared plus cos theta squared is equal to 1. So we know that sine theta is A over C. Cos theta is B over C. And this is asking for sine theta squared and cos theta squared. So sine theta squared would be, sorry. Right, sine theta squared would be A over C squared, and cos theta squared would be B over C squared. So that would, this now, when we multiply this, it would look like A over C times A over C. I'm just going to put my plus sign there to show that that's where we are. And some brackets as well, for some clarity. So A over C times A over C, and B over C squared is going to be B over C times B over C. All right, so when multiplying these across now, we're going to get A squared over C squared, A times A squared, C times C squared, plus B times B squared, C times C squared. All right, so at this point, we have A squared over C squared plus b squared over c squared. Here we have a common denominator. Once again, we have c squared being our common denominator. So we can rewrite this as all over c squared, a squared plus b squared. So what is convenient about both of these numbers is, well, before I get to that, we can bring back to knowledge Pythagoras' theorem, which states that, because this can be broken down further, because we're trying to show that it's equal to 1, we can remember that Pythagoras' theorem shows that c squared equals a squared plus b squared. So from that first part where we represented c in terms of a and b, we can bring back this part to knowledge. With that said, we can transpose for either a or b in terms of c and a, if you're transposing b, and c and b if you're transposing for a. Now, how would that look? Basically, what I'm saying is that a squared, so if I bring over, right? If I bring over a squared is equal to c squared minus b squared. And this, once again, is another part of Python, but just showing or proving how we get those parts. So a squared is equal to c squared minus b squared. You can transpose on your own and see that b squared is also going to be equal to c squared minus a squared. And with all of this knowledge, we can bring it back down here. And for any one of these, we can rewrite in terms of, for A, we can rewrite in terms of B and C. For B, we can rewrite in terms of A and C. And I'll get to why we would do that in a second. You would realize why we would do that. So here I'm going to write A in terms of B and C, and that would look like, so where A is, I'm going to replace it with this here. A in terms of B and C, A squared, sorry, in terms of B and C squared. So it's going to be C squared minus B squared plus B squared over C squared. All right, so here you have C squared minus B squared plus B squared. And we can remove those brackets because all of this is being added and subtracted. So you can work without brackets here. So with that said, we have B minus B, B squared minus B, and this can then be canceled out. So I'm going to write in a new line, C squared, rather than write out the actual thing fully. Right. So I switched over the positive B and the negative B. I switched them and put them over C squared. All right, so C squared plus B squared minus B squared all over C squared. B cancels out B, and we're left with C squared over C squared. And as we know, if we're dividing a number by itself, even if it is an unknown number, as in this case, it is always going to be equal to 1. So C squared divided by C squared gives us 1. And that is how we know that all of that is equal to 1. So going back to the beginning, the first thing that was done was basically rewriting these terms in terms of A, B, and C. So rewriting these using our letters, A over C and B over C. You square those, A over C squared, B over C squared, and we got these as a result. After that, we rewrote, I guess, A squared plus B squared over C squared. And once again, you can rewrite either A squared or B squared, it's up to you, in terms of the other two letters. So I chose A squared. A squared is equal to C squared minus B squared, C squared minus B squared plus b squared over c squared. I switch those, and positive b squared cancels out negative b squared. We're left with c squared over c squared, which is equal to 1. All right. So with that said, how confident was everyone doing this question? Are we okay with the question? Can we move along, or we're not sure what's happening?
You can move along.
Okay. All right. So before I get into the next topic, let's look at some paper 1 style questions under geometry and trigonometry. Okay, so in a triangle, angle BAC is equal to 30 degrees and AB is equal to 40 meters. The length of BC in meters is, and we have these down here. So BC is our line right here, and we are told that AB is 40 and our angle is right here at A. So first of all, and of course, as you can tell already, this is a question about trig ratios. So first of all, you would want to identify the sides that are there and the sides that are in question. So you know the hypotenuse, which is AB, and you're being asked to find the length of the opposite side, which is BC. So off the bat, the ratio that is brought to mind is sine SOHCAHTOA, sine theta equal to opposite over hypotenuse. And with that said, we can then try replace our unknown values with our known values. So sine theta here being our 30 degrees, so we're just going to put sine 30 equals to opposite, our opposite being BC. So I can just put back BC there because we don't know what BC is, over the hypotenuse, which is 40 meters. So already you can start to look at the responses that are there for you to choose from, and you can tell that, okay, B and D are out because they're using tan, and you're trying to use sine. And in addition to that, you're working with 30 degrees, not 60 degrees. So already you can probably pick out A. But before we get to that, and if you want to go all the way, you can actually transpose for BC to find what the answer is supposed to look like. So here, sine 30 equal BC over 40. We can bring over that 40 here. We're dividing here, so we're going to multiply on this side, and that's going to look like 40 sine 30. All right, so just an explanation of how this is your answer, sine 30 degrees. Moving along to item 60, the diagram above, not drawn to scale, shows the angle of depression of a point X from Z to is 30 degrees. If X is 10 meters from Y, the height YZ in meters is, so here this is angle of depression question. Basically, they're giving us our angle of depression at 30 degrees and our distance from that point being 10 meters. Once again, it is asking about trig ratios. So what we do, we identify our sides that we're given and our missing sides. Our missing side here is Y, Z, which is here to here. And we know one angle, which is this one here. So there are two ways that you can look at this. You can actually, this angle is equal to this angle here, and because it is on the same line there, so when it forms a Z shape like that, the angles that are in those corners are the same. So this is going to be 30 degrees as well. You can look at it as opposite over adjacent, and that would be tan. So it would be tan 30 equals yz over xy. Sorry. So tan theta equal opposite being xy over adjacent. And replacing those values would be tan 30 equal yz, because we don't know what yz is, over 10. So once again, like before, we bring over our 10, and that would look like 10 tan 30. And just as before, if your choice was to use the process of elimination, already at the first step, you would have your answer because you're working with tan here, and the only option that uses tan is option A. And if you went all the way, you'd get your 10 tan 30. All right, so I'm going to move along. No. All right, so let's do these two questions here. All right, so once again, still on geometry and trigonometry. In the triangle ABC, not drawn to scale, AB is 17 centimeters, AC is 15 centimeters, BC is x centimeters. The angle BCA is 90 degrees. The value of x is, all right, so here we know that this is a right angle triangle. Usually that's what we're working with, but we can see a right angle right here. In addition to that, we can identify our hypotenuse, which is the 17 centimeters, side AB, and we can identify the other two sides. So it is asking us for the length of a side, and it has given us the length of two other sides, which means that more than likely we're going to have to use Pythagoras' theorem. And this is a right angle triangle, so we're definitely going to use Pythag. And we're going to rewrite this all the time, but Pythag states that c squared is equal to a squared plus b squared. Or if you want to write the other way, c is equal to root a squared plus b squared. So with that said, we can fill in our known values. We know the value of c, which is our hypotenuse, which is our 17 centimeters. So 17 centimeters is equal to 15 centimeters plus x centimeters. So I'm going to write my root sign, or rather, okay, so I'm going to work with this Pythag equation. So I'm going to rewrite 17 squared is equal to 15 squared plus x squared. X squared being our side over here that we don't know, and 15 being this side right here. So 17 squared minus 15 squared is going to be equal to x squared, and that is just bringing over that 15. And with that said, we can find the value of x. So you can square 17 on the spot and square 15 and subtract 15 from, subtract your results, and then you can find the square root of that. But for time, I'm just going to do that part on the calculator. All right, so 17 squared minus 15 squared is giving me 64. As I said, if you want to, when you're in the exam, you'd have to do that part on the paper, because this is paper 1, of course. So 64 is equal to x squared. Bringing that over this side, what we do when we have a square sign, we use our square root on both sides. So root 64 is equal to root x squared. And these cancel out each other, and the square root of 64, as we know, is 8. So 8 is equal to x. And here, 8 is that answer B, so you're just going to choose B. All right, moving along to question 58 here, or item 58 here. In the isosceles triangle shown above, the value of x is, all right, so here, this requires our knowledge on triangles, more specifically, isosceles triangles. So the main idea of isosceles triangle is that the angles at the base of the triangle, which are the angles that are at the base of the equal sides, both of them are equal. So there are only two equal sides in an isosceles triangle, and the angles at the bases of those sides are equal. So here we have our two equal sides being shown by our ticks there. And we have one of those sides, which is 30 degrees. So because this is an isosceles triangle, we know that the next angle that is opposite to it, or at the other base, is also 30 degrees. Now we know that, but we're trying to find x. So what we would do from there is basically use our other thing that we know about triangles. All of the angles in a triangle sum up to 180 degrees, and subtract our 30-degree angles there. So I'm just going to put 2 times 30. We have two 30-degree angles there, and then we would find the result from that. So 2 times 30 is going to give us 60. 180 degrees minus 60 degrees is 120 degrees. That is option C. All right. So we're good with those questions?
Yeah, we're good.
All right, great. So functions, graphs, and relations. So let's attempt some questions on our functions, graphs, and relations. So starting off as same as before with some paper 2 style questions. So given the function h of x is equal to 2x plus 3 over 5 minus x, give the value of x for which the function is undefined. Focusing on this first part right here. So when a function is undefined, it basically means, and it's related mostly to when you have functions that have some sort of fraction in it, so some sort of division. It basically means when you're dividing by 0 in the function. So whenever your denominator is equal to 0, and you can try in a calculator right now, whenever the denominator of a number is equal to 0, it is undefined. It will show you undefined. Basically because we can't, or we don't know how to divide by 0. So with that said, we're trying to find out what value of x makes our denominator 0. So when they say value of x for which the function is undefined, they're asking you for the value of x which makes the denominator equal to 0. So here I'm just going to rewrite the function h of x equal to x plus 3 over 5 minus x. So we're trying to find the value of x here that would make this denominator equal to 0. So what you can do is equate what is in your denominator. Usually there is an x value there. Equate what is in your denominator to 0. And you can find out exactly for which value of x would make the denominator equal to 0. So 5 minus x, which we have here as our denominator, is equal to 0. We can bring over that 5, and that would give us a negative 5 on that side. And we are we're multiplying by negative 1. So dividing by negative 1 over here is going to give positive 5. I know that was a bit fast. I'm not sure if everybody is good with that, but yes. So go over it? Okay.
Yeah.
All right, so let me clear. Sorry about that.
That's fine, man.
All right, so 5 minus x equal to 0. So once again, as I said, bringing that denominator here, equating it to 0. So 5 minus x is equal to 0. I need to get rid of everything over here that is not x. Basically just want x by itself. So I'm bringing over first that 5. So So it's going to be negative x, sorry, 5 minus 5 minus x is equal to 0 minus 5. So basically, that's what I just did the last time. So 5 minus 5 minus x, just the same, equal to 0 minus 5. Now we know that 0 minus 5 is going to give us negative 5, just the same. 5 cancels out 5 here. So 5 minus 5 is 0. And we have negative x. So now that we have negative x and negative 5, we can cancel out that negative sign right there, which basically means the same as negative 1 times x. So quite literally right, negative 1x. So negative 1 times x, and I'm multiplying here, so I'm going to divide by negative 1. And I do the same. Whatever I do on one side, I do the same on the next side. Negative 5 divided by negative 1. And a negative divided by a negative gives me a positive. 5 divided by 1 is going to give me 5. So this is going to be positive 5. Negative 1 cancels out negative 1 here. So that is why we have x equals 5. And whenever you do this, you would want to actually try to see if you would get your denominator to be equal to 0, or if you type in everything in the calculator, you would get 0. So h of 0, so h of x is equal to 2x plus 3. I'm going to replace x with 0. So h of, 5. Excuse me. So I'm going to replace x in the, and this is just to prove that this is undefined. I'm going to replace x with positive 5 equals 2 times 5 plus 3 over 5 minus 5. 5 minus 5, 2 times 5 here is going to give me 10 plus 3 over 0, 13 over 0. You can plug that into your calculator and see that it would show that it is undefined. So as I said, if it's asking for you to show the value of x for which the function is undefined, undefined means that the denominator is equal to 0. So you can start from there, equate your denominator to 0, and find the value of x that would make the denominator equal 0 or the function undefined. All right. Over here, part 2, we have an expression for h inverse x. So basically, this is asking for just the inverse of the function. So you see that you're being asked for the inverse of the function. So when calculating the inverse of or in finding the inverse of a function, over 5 minus x, it is basically, you have two different ways you can do it. You can swap first, where basically you swap your y values. Wherever you see y, you put x. Wherever you see x, you put y. You can swap first and then you isolate x, or isolate, and then you isolate x, or you can isolate, one more time. You can swap first and then you isolate y, or you can isolate x and then swap y for x. So, but the two steps are all the same, are always the same, I should say. Swap and then isolate. Well, I should have switched them because I'm going to isolate first and then swap. So reason why is because it makes me realize that I am not complete with the problem as yet, so I don't stop prematurely and put the wrong answer there. So I'm going to isolate for x first and then swap x for y. So y is equal to 2x plus 3 over 5 minus x. This is my denominator here, and when we have something in the denominator, we usually not necessarily get rid of, but we put this aside first. So we transpose this first. So 5 minus x is dividing here. So we're going to be multiplying. And that would be 5 minus x, y equals 2x plus 3 over 5 minus x times 5 minus x. So because I'm multiplying now, we can cancel across. So this is going to be 1. 5 minus x times y equals 2x plus 3. We can rewrite all of that as is because we got rid of the denominator. So it's 5 minus x, y equals 2x plus 3. So with that said, we can now, because we're trying to get x by itself. So always remember the goal, trying to get x by itself. So we can multiply here. We have 5 minus x being multiplied by y. So that's 5y minus xy. If I bring so just explaining what I did there, if I bring my y over here, multiply my 5 times y, I get 5y. And if I multiply my y times x, negative x, I would get negative xy or minus xy. And we rewrite what we have over here. All right, so with that said, once again, remembering the goal, getting x by itself. So I have x on this side and I have x on this side as well. So I want all of my x's to be over here and everything else to be on the next side. So what I'm going to do is transpose twice. I'm going to bring over the 2x over here, and I'm going to bring the 5y over to the next side. Now, this part is up to you, however you feel it is best to do it. I'm just going to explain everything, how I get that to be here. So 5y, positive 5y, so I'm going to subtract 5y over here minus xy is equal to 2x plus 3 minus 5y. 5y cancels 5y. So I'm going to be left with negative xy equals 2x plus 3 minus 5y. All right. So I brought over my 5y and I'm going to bring over my 2x, so I have it on this side. So negative xy minus 2x equal to 2x minus 2x. So that's why I have negative 2x over here, minus 2x over here, plus 3 minus 5y. So I can cancel all of this now. Okay, so now I have my x on, all my x's on one side. I can factor out x right here. So x outside, and x going into negative xy is going to be negative y. X into negative 2x is going to be negative 2. And all of that, as we know, is equal to 3 minus 5y. So running out of space, but the last step, this is just the last step now. So now that x is by itself, but it's beside this bracket here, all we have to do is bring it over to this side again. And we're multiplying, so we're going to divide. So x, and let me just put some lines here. All right. So x negative y minus 2 equal to 3 minus 5y. I'm going to put everything over negative y minus 2, all in brackets. So I'm just using the brackets there to separate it from everything else. So we can cancel negative xy minus 2, negative xy minus 2. And here we have our result. So it's going to be x equal to 3 minus 5y over negative y minus 2. So as I said last time, as I said before, I isolate first before I swap, because as I can tell here, I have x and a function is written as, well, normally written as x equal to all of this. So now I want to swap x for y. So that is going to look like y equals 3 minus 5x over negative x minus 2. And that would be the result for that question. Sorry, that problem. So y equals to 3 minus 5x over negative x minus 2. So the rule of thumb is always these two steps, swap and isolate. If you want to isolate first before you swap, or swap before you isolate, the steps are always the same. Okay. Moving right along. So the graph below shows a straight line intersecting the x and y axes. Using the graph, determine the gradient of the line. So first part, determine the gradient of the line. All right, so we're working with our graph here. There's not necessarily much calculation, but let us look at this. So when using a graph to find the gradient of the line, the method that is usually used is the rise over run method. Rise over run. Of course, you can approach it another way, but I'll be looking at it this method. So what I will do here is basically the first step, always the rise over run, is to construct a right angle triangle. So I'm going to construct my right angle triangle here on this axis, on the axes themselves. And it is going to just meet with that line where they actually meet the axes. Reason why I use that is because it's always best to use as big of a triangle as you possibly can. Also, it's nice to be able to meet the line where, at a particular point, or at two exact points. So that you just have an easier time when you're trying to find your rise and your run. So with that said, I am going to get into actually finding now my rise and my run. So my rise here and your rise is found basically from that right angle point there, that is opposite to your hypotenuse. So your point right here going up. So, or rather, right, so with the rise over run method, you're trying to move from where your triangle meets your line. So right here, going this way and then going up or down. So from here, going here, going here. So I could find my run first, and I'm going to do so mainly because of the orientation of the line. So I'm going to find run first. This is going to the left. So that means that it is negative. And you don't want to miss that when you're dealing with the rise over run method. You want to also see the direction that you're going when you're following the triangle. So I'm going to the left here, and then I'm going up. So I'm going to the left. That means that my run is going to be negative. I'm just going to put my line there. My run is going to be negative. Let us find what the run is going to be. So counting across here, it's going to be 1, 2, 3, 4, and 5. So my run seems to be negative 5. My rise, coming up from that same point right there, and we're moving upwards, so it's going to be positive. 1, 2, 3, and 4. So it's going to be positive 4. All All right. So as I said, you really want to always pay attention to the direction that you're moving. And you can tell usually from how the line is turned. So if the line is turned upwards, it usually has a positive gradient. If it's turned downwards, the gradient is going to be negative. So here our gradient is going to be negative because 4 over negative 5 can also be written as negative 4 over 5. All right. Moving along to the next part of this question. Using the graph, determine the equation of the line. So here, the first thing that should to mind is the format of the equation of a line, which basically states that y equals x plus c. M being your gradient, c being your y-intercept. These are the only two things that you need when you're trying to find the equation of a line. So whatever format whatever approach you're taking when trying to find the equation of a line, the main things that you're trying to find are your gradient and your y-intercept or your c value. Okay, so we know that we know the value of m, which is what we just found, negative 4 over 5. Now we are trying to find the value of c. So to find the value of c using your graph, all you need to do is to see where the line meets the y-axis, hence the name y-intercept. So our line meets the y-axis right here, our y-axis being this line, our vertical line going upwards, our vertical axis. So it meets the y-axis right there. Let me switch to this one. Meets our vertical axis right there. And now let's look at the coordinates of that point. So if we're starting here at 0, and we're going up by 2 units per square, per big square. So 1, 2, 3, 4. So right there looks like it's 4. All right, that is not clear. All right, let me write on this side over here. So the units for that, the coordinates for that point, 0 on the x-axis, and 4, we're going up by 4 on the y-axis. So it's going to be 0, 4. So our y-intercept is going to be at 4, positive 4. So the value of c here, c is equal to 4. So we can write our equation of our line using just our gradient and our y-intercept. So it will be written as y equals negative 4 over 5 times x plus 4. So negative 4 over 5x plus 4 is going to be the equation of this line. Okay, moving right along. Okay, so now we are being asked to find the equation of the perpendicular line that passes through P. So the point P here is this point down here. Let me highlight that for you. So that point right there. So it's right here on the x-axis. So the first thing to do is to find out the coordinates of, so we're given the knowledge that this is a perpendicular line, and we're given also where the point where it passes. So it's point P, it's a perpendicular line. It is perpendicular to this line, I should say. So let me start off with the perpendicular line. And we're looking for the equation of the line, so we need M and we need C. All right, so with that said, let us actually find the equation of the line. So I'm going to line. Basically, when it's stating that a line is perpendicular to another, it means that the product of the gradients of both of those lines is equal to -1. So let's say, for example, we have line 1, gradient of line 1 times the gradient of line 2. That is going to be equal to -1. So the product of their gradients is -1. We know the gradient of one line here, which is -4/5, the gradient of the line that we're given, but we don't know the gradient of our missing line, or the line that we're being asked to find the equation of. So I'm going to be multiplying that by m2, just the same, just keeping that m2 there. But I do know that they're perpendicular, so the product of their gradients is still -1. So using this approach, we can just isolate for m2 and transpose everything else. So transposing this -4/5, bring it over that side. Because we're multiplying over here, we're going to be dividing. So if I say -4/5 divided by 4/5 times m2 equals -1 divided by -4/5. This cancels out, this will give me 1. M2 is equal to -1, and we can use our keep, change, and flip. So -1 times, flip this, 5, sorry, -5/4. All right, so multiply here, multiplying across. -1 times -5, a negative times a negative gives a positive. So that is going to give me +5. And m2 is equal to 5/4. So m2 is equal to 5/4. And after a time, while working with perpendicular lines or lines that are perpendicular to each other, you will be able to just readily look at the gradients and find the gradient of the line that you are trying to calculate. So I'm running out of space. I'm just going to give you a second to have this before I erase. So m2, or m, equals 5/4. Now let's look for our step. C equals 1. All right, so we're given our point P. So we can look at our graph and actually find the coordinates of P, which are 5, 0. So it's going to be 5, 0, I guess. So P is 5, 0. So it's 5 on the x-axis going across. So 1, 2, 3, 4, 5 right there, and 0 because it's lower on the y. So with that said, we can use this as well as our gradient that we just found to find the actual equation. Sorry, to find the y-intercept, I should say. So I'm going to rewrite the equation of a line equal to x plus c. And I'm going to write my values that I now know. So y here being 0. So you're going to take y and x from the point that you're given. So y is equal to 0 and x is equal to 5. Our gradient is 5/4. So I'm going to write 5/4. X is 5 times 5 plus c. So 0 is equal to 5/4 times 5 plus c. With that said, we can find the value of c now by just calculating this here. So it's going to be 25/4 plus c. I can bring this over, so I have c by itself, and that would be 0 minus 25/4 4, we're adding, so we're going to subtract. And this is positive, so we're going to subtract. And it's equal to 25 over 4 minus 25 over 4. All of that there can be cancelled. Let's see. So what this is telling me is that negative 25 over 4 is equal to C. My C value is negative 25 over 4. And rewriting this as a mixed fraction would look like this, 6 1/4. All right, so the value, the C value here is 6 1/4. Let me finish this up. So yes, now knowing my C value and my gradient, my y-intercept and my gradient, I'm just going to write the equation of this line. So your answer would be here. Y equals 5 over 4x minus 6 1/4 or minus 25 over 4. It is up to you how you want to write that part. And that should be it for this question. All right. Everybody is still clear on where we're going. I know that time is short, so I'm just going to look at, one paper one question, I guess.
Yeah, that's fine.
Okay. All right. So I'm just going to look at one paper one question because the hour is up. Yes. All right. So R2. Let's start here. All right. So the equation of the line, starting with this right here, the equation of the line which passes through the point 0, 5 and has the gradient of 4 is, all right, so here we are missing we're missing one thing, which is our y-intercept. So we have our gradient n equal 4, and we have a point which is 0, 5. So just like that last step that I just did in the previous question, you would want to do that here so you can find the equation of your line. So y equals n is 4. Yes. So I know the value of y, and y is equal to 5. 5 times 4, 5 equals 4 times 0, 0 being my x value, minus c, plus c. So 5, 4 times 0, 4 times 0 is going to give me 0. So 5 is going to be equal to c. So as it says here, there is a response already that has 4 being the gradient, m equal to 4, and 5 being the y-intercept. All right, moving along. To this second question here, x squared minus x minus 1. If f of x is equal to x squared minus x minus 1, then f of negative 5 is equal to what? So when it is written like this, basically it's asking for us to replace wherever x is with negative 5. So that would be negative 5 squared minus x is there, so we're going to minus negative 5 here, minus 1. Negative 5 squared, so negative times negative gives me a positive, and 5 squared is 25. So I'm going to have positive 25 there. Minus negative 5, so we're subtracting a negative. That means that we're going to be adding, so it's going to be plus 5. Minus 1, just the same. 25 plus 5 minus 1, 25 plus 5 gives me 30. 30 minus 1 gives me 29. And 29 is option C. All right, so this item 47, the straight line AB cuts the.
Rochelle, mark C for the first question. I forgot to mark it.
Oh, yes. A. Okay. Right. 4 and 5. Okay, so item 47, straight AB cuts the y-axis at. All right, so basically they're just asking for the y-intercept. So all you need to do here is identify your y-axis, which is right here, and where the line cuts it, which is at -2. So they're asking for the actual coordinates of that point. And here you would realize that it would be 0 for x. It's moving nowhere on x, and -2 for y. So that would be 0, -2, which is D. All right, so item 54 refers to the following diagram. In the diagram, AB and CD are parallel. Which of the following best describes the relation between X and Y? Okay, so this is similar to what I was explaining before when you have your parallel. So this is actually showing the parallel lines and the transverse line that's going between both of those, going through both of those. When you have that Z shape there, the angles that are within that, those corners are going to be equal. So TLDR here, A would be a response because X is equal to Y. So if this were 30 degrees, this is also 30 degrees. 60 degrees, this would also be 60 degrees because this line here makes those two angles equal. And I will leave it at that.
All right. Thank you so much, Rochelle. I really appreciate it. Stop sharing for a bit so I can.
All right. You're welcome. Thank you for having me.
It was a pleasure, trust me. So just a few housewarming things. So for everyone who is listening right now, and for those who will watch it after the live has been posted, because I always repost the lives and ensure that they're up for those who want to watch them later, because I know it's kind of sticky with the timing, like, 5 p.m. might not be good for some of you. We're on break now, right? That's what's happening. I don't know. Like, I want to say that probably you're coming from school, but I don't even know if school keeping now. Today's a holiday. Today is Earth Day, but that's not a holiday. Anyway, so
guys, still on break.
All right, great. So what you want to do is go over to our Instagram page at young_genius.official and follow us there so you know when we're giving away freebies, because you don't want to miss those. And the marathon, we're having a CSEC mathematics marathon on May 7th. There are still seats available, so you can message me on IG, or you could message me on WhatsApp or by direct message, if you use SMS and them thing there, at 876-501-1966. That's 876-501-1966. Or you could email me at younggenius.educate@gmail.com. It's 2 G's, so young, YOUNG, genius, GENIUS.educate@gmail.com. And thank you to Rochelle Robinson. That's one of our mathematics tutors. Thank you for facilitating this session. And before I forget, tomorrow we're having another freebie session. This is CSEC Spanish. You can DM me on Instagram for the Zoom link, or you could DM El Aula on Instagram for the Zoom link, because we're doing another collaboration. Earlier this year, we did a collaboration with El Aula. We went live on Instagram and we talked about business or starting a business as a young entrepreneur. So you don't want to miss that collab with El Aula. It's going to be a very good one. And check out our Instagram. Finally, again, help us to get to 1K followers on Instagram, and follow my personal page. Well, it's not personal, but it's still a business page at _CAM_EO. My name is Camille, by the way. Yes. So yeah, I think that's everything. And I have seen your messages. I have seen your messages on IG. I've seen your messages on WhatsApp. I'm just a bit slow to answer because I have a lot of work doing right now, as well as a lot of messages to answer. So I'm getting to them. Don't worry. I'm answering your messages. And about the sessions for CAPE Physics, Communication Studies, and CSEC Physics, I'm not sure if I'll be able to, but I'll most definitely try to work those out for you. And we're also having our CSEC Physics Marathon this year. So you can go over to our Instagram and check the page for the marathons that we'll be hosting this year. So thank you for tuning in, guys. Until next time, bye. Drop a like on the video, show Rochelle some love, and subscribe. Get us to 3K subs on YouTube. And thank you again, everyone, for your undying support. I appreciate it. So bye, guys. So I'm about to end the stream. It's just a little warning, so you don't see it just stop like that. Yes, I'm going to end now. I hate doing outros though. Oh my God.